Good afternoon, ladies and gentlemen. I would like to express a warmest welcome to the ITS Hong Kong 2023 Technical Webinar Series today. I'm your host for this afternoon's webinar. For those we have been long-standing members and supporters of ITS Hong Kong, you would know that ITS Hong Kong had for over many years been organizing regular technical seminars, forums, and visits with the objective of providing a professional platform for members of the ITS industry to share their expertise and experience, bringing benefits to the local and regional development of ITS. Our event today will be around an hour, with around 45 minutes for our speaker's presentation and around 15 minutes for the Q&A section. Today, we are delighted to feature with Esme One Ltd and their partner Teledyne FLIR to speak to us on the topic of how to make your urban traffic safer, smoother, and smarter. With us today is Mr. Joris Blayton, ITS and Security Training Manager of Teledyne FLIR. Before we start, may I request all audiences to mute their microphones so that we can minimize any interruptions to the presentations. Questions are more than welcome. Please type your questions to the speakers in the chat box. We will be reading them out to the speakers at the later part of the event for their feedback and discussion. Now I will hand over the floor to Joris. Thank you.
Thank you very much for this introduction, and thank you very much for having me along with our partner Esme here on this platform. And I'm happy to share with you our applications and solutions that we have to make your traffic safer, smoother, and smarter. So I will do that by sharing my screen. So here we are. So welcome again. On how to make your urban traffic safer, smoother, and smarter. So my name is Joris Blayton. I joined Teledyne FLIR in 2008. To be honest, in full disclosure, I have to tell you that we changed already a few times from name since we are now becoming and now are Teledyne FLIR ITS. I've always been involved in training, explaining to people around the world what the Teledyne FLIR solutions are and how they can work for you. So, and today, in the next 45 minutes, maybe a little bit less, I will be your host and tell you more about these solutions. As mentioned before, please, if you have a question that's popping up during this presentation, drop it in the question box. But just to remember, I will ask from time to time also a question, and you can drop your answer in the question box or just something to reflect on. So welcome again. I mentioned, and I dropped a few names, Teledyne FLIR ITS, just a few words of explication. Let's start with Teledyne. So Teledyne Technologies is an American industrial conglomerate. It provides enabling technologies and mainly for industrial growth markets, because these markets require advanced technology and high reliability. And one of these key technologies are sensors. In fact, to simplify things, if you know or maybe still remember your physics lessons with the electromagnetic spectrum, you have this range of frequencies of electromagnetic bandwidth of gamma radiation on one end and the radio waves on the other hand. Now, Teledyne has for each of these frequency regions a type of sensor. In 2021, they acquired FLIR. In that sense, they were now complete, because with the FLIR in their portfolio, they strengthened their thermal frequency range. And FLIR has been for decades already a specialist in the design and production of thermal imaging cameras and sensors. The ITS part in Teledyne FLIR ITS refers to the department which offers already over more than 30 years intelligent transportation systems. And these technologies are based on video image processing, using really advanced video analytics. And ITS will help you as a customer, as an integrator, as a consultant, to create in the field of traffic a smarter city, not only for traffic in cities, but also for highways, bridges, in tunnels, in rail transport. We offer our technologies to handle these traffic situations in a very efficient way. And simply put, we ensure a safer and smoother traffic worldwide. And the nice thing about video detection is that, yeah, it says video. So we have video to tell you what we do. So we have a few movies to share with you, and that will tell you already a lot of what we are doing before I dive into the details. The first one that I want to show you here, yeah, there it starts, is about, and that's the one we're going to mainly focus on today, that's the one that is talking about how to detect traffic at intersections in cities. And in this example, what we want to do here with our sensor is detect the presence of vehicles approaching a stop bar. And as you can see on this image, well, we tell you already who is approaching, because it's quite well labeled. And based on the information, you then can change your traffic lights. But it's not only about smart city solutions. We also are involved in automatic incident detection on highways, as what you have seen here. An incident happening on a highway where this car crashes against a wall, as you could say, and then is causing a lot of debris, but also injuries maybe to the driver. We want to give that alarm to a traffic signal controller so they can assess and act very fast to make sure that there's no secondary incidents, because as you can see, traffic is piling up and maybe causing worse accidents than the first one. And also within the within the tunnel environment, we offer quite some solutions. Here is one where we were going to detect a fire in that tunnel. And please note the timing. So here 10 to 6, we notify already, or we see already, that there is in fact a car standing still and on fire in that tunnel. That happens 3 minutes to 6. And not only 3 minutes later, the whole tunnel is already closed. Firefighters are being warned, and 80 minutes later, they're already up and running around there and trying to close, to extinguish the fire. And in total, an hour later, the tunnel is already available again for operation. I have a small question for you, and you can drop it, or you can think about it, or you can drop it in the chat box if you want to. So with this webinar, what question would you like to have answered at the end of this question? And I hope I will answer it. And anyhow, please drop it in the chat box, then we will answer it for sure. I give you a few seconds time to do so. Great. Now, by participating to this webinar, you showed you're interested, that you want to know how our solutions could make your traffic smoother and safer. But before I dive into that, I want to talk a little bit more about the architecture of our system. You have to know that in a city, if you look to a city, there are different stakeholders involved in it. What we have out there as stakeholders, we have motorists, we have cyclists, we have pedestrians, and each of them, they claim a portion of the public space. They each want to reach their destination as quickly and safely as possible. And solutions are out there needed to make that happen. to make things go smoothly and safe for everybody. And Teledyne has those solutions. Solutions using visual and thermal technology, which will allow you to detect vehicles, but also pedestrians, cyclists, and so on. Now, when we look at an intersection, what we have out there, we have our traffic lights. What are we going to do is we're going to position on a pole, on a gantry, we're going to position our cameras, our sensors. And they monitor the road, the intersection. What can happen? First of all, the moment that we analyze, because the analysis is happening inside the camera. So the camera analyzed the image, we detect a vehicle, we detect any stakeholder, and that can result into a close contact. Close contact that goes to the traffic signal controller, and that traffic signal controller can then change the lights from red to green, from green to red, whatever is needed at that moment. But it's not only that we can do. It's also possible because more and more controllers, they start not only to work with just contact closures, they're also working on XML, on HTML, on really IP data. We can also, using a public API, send that information to that traffic signal controller. But that same data, if you want to, you can also store it on a server, a database that you have. That can be yours, but it can also be ours. That's, for instance, Flux. And there's even the possibility nowadays, and I will explain a little bit later what is the difference between that Flux and that other one, the Acyclica, that is a cloud solution. You can even store stuff in the cloud, giving it access all aboard everywhere. So that is our architecture. Now, what do we do within that scene? What are the applications involved in there? So that's the next thing that I want to talk about with you. And I mentioned already a few of them. The first one is everything related to traffic signal control. As mentioned before, we're using thermal and visual sensors. There is a slight difference, and here you see two examples where on one hand, I have a visual sensor, and on the other hand, I have a thermal sensor. And I hope that the video will start. Let's see what happens. Yeah, so there we have our visual sensor, and you saw already a bit before. So with a visual sensor, what we have out there, we have a zone where we want to detect a vehicle approaching, or in this case, really stopping at the stop bar. And we can even make a different output depending on who's stopping there. So you could make a different output if it's here a car, and in this example, a large truck. This is even, in fact, one of the e-versions. Now we can even tell that that large truck is in fact a bus. So we can even, or you can even say, no, activate an output for me when it's a bus. Here we do it on all lanes exactly the same, but you can do it differently. The other one that you see right here is exactly the same, but using a thermal camera. This thermal sensor has also the big advantage, and you noticed on the sidewalk on the side, where we have a zone to detect vulnerable road users as cyclists. This, because with thermal, we can do that way better than with visual. Surely at nighttime, how can you detect there is a pedestrian, or you need some light? If you don't have light, then a thermal sensor is way better. Another thing that I want to show you here, and we activated here on that thermal camera, is that you notice that each car, you see where it's driving, but you also notice that it's a car, at what speed it's approaching, or it's at the stop bar. So you have different classes and you see them out here. So that's about traffic signal control, mainly focused here on vehicles. But I could do so exactly the same thing with vulnerable road users. This is not an intersection, have not an image yet on that, but showing you already with this video clip, and I hope that it will start. There we are. So if I start that clip, you notice that I'm not only detecting cars, but I'm also detecting these pedestrians at the back. I speed up a few things because I want to show you also a cyclist. So there is a car, but there is also a cyclist approaching. The moment it gets closer, we really identify it as a cyclist. And I can assign an output to that or collect the data for that. I have that information. That's the vulnerable road users, but here focused on traffic signal control. But it's not only for that. I can also use, and that's another application, is where I want to detect vulnerable road users. In this example, a pedestrian at this, yeah. So the clicking sound that you hear is in fact the clicking sound of that traffic pole. So that lady is pushing the button, but the push button doesn't do anything anymore. It's in fact now a sensor on top of the other pole on the other side and detecting the lady here with her umbrella. With this sensor, we are really completely replacing the push button. The push button is there, in this example was just there, yeah, to give still the people the feeling that they have control it, but it's in fact a sensor that does the detection. So the moment that, yeah, traffic signal identifies it's safe to cross, she will be able to cross. Now, a nice example is what is happening next. So this person is now pushing the button. The alarm goes to, or the event goes to the traffic signal controller, but he walks off. But the call is canceled. So you don't hear the clicking anymore because the call is canceled. Yep. Another example for vulnerable road users and not immediately related to traffic signal control is, for instance, this example where we detect a pedestrian crossing. And the moment they are crossing, we have the alarm. It's not an alarm that's constantly flickering, telling the cars driving by, hey, there's a potential dangerous situation because people are walking by. No, we're only going to give the alarm the moment somebody is really either entering that crossing or really already starting to cross. Then we're going to start the flickering. The activation goes to that particular alarm, to that particular light. Another application where we can help is in collecting traffic data. So wherever your camera is positioned, and when you activate that functionality or the functionality is available on that sensor, you can start collecting traffic data. And here is an example where we use the camera on the side of the road, collecting data where there's free flow, where there's constantly people driving very slow or very fast or in normal pace. We are collecting data. Here you see already in the black corner a few information, but we have way more information that we're not displaying just on the screen that you can download from that sensor and capture it on your server in our management systems as Flux and as Cyclica. So here we have that. Another example is when you have the question, hey, I would like to know, for instance, the classifications, how many cars, how many trucks, how many buses stopped at my intersection. Well, at that moment, you can also activate, it's not jumping. Yeah, there it is. So the other one is now kicking in, but the car is standing still, is waiting. So here, what we do here we are collecting data on the speed of these vehicles, but also the classes of these vehicles at the intersection. That's traffic data, collecting traffic data either in FLIR flow or looking at the stop bar at the intersection. But that's data about the location where that particular sensor is positioned. But there's also the possibility, if you have a Wi-Fi enabled solution of us, then you can use also that Wi-Fi to collect data. And here's an example. So what we have here, we have in this example, 2 intersections. Each intersection has at least 1 or 2 or even more sensors where the Wi-Fi is enabled. And what can we do now? The moment there is a vehicle passing by with either the Wi-Fi of the vehicle is enabled or somebody sitting there with a mobile phone enabled, we can take on that MAC address of that device. And okay, it's hashed and it's secured, but we can take it along the route between all these sensors. And what gives that now to an advantage? Well, multiple advantages. First of all, what we can do is we can know, okay, how long did it take, for instance, to get from the beginning of the intersection till the end of the other intersection? What was the maximum time it took to get from one intersection to the other section, or from the intersection to the other intersection? And that's the strength, from the strongest point of the intersection, or getting out of the first one and getting towards the second one. But it's now between 2 intersections. Imagine that you have multiple intersections. In that way, you could create a report that says, tell me, how long did it take to get from the northern part of my city to the southern part of my city? And even go more in detail and tell you, hey, maybe it took half an hour, but then you check, wait a second, every intersection that takes about 5 minutes to cross, but that one, it takes 10 minutes. And then you can investigate why. Maybe you can improve to make sure that it's everywhere 5 minutes. So you speed up, make things run much smoother. So that is how you can collect data at an intersection. So we have 3 applications, traffic signal control, vulnerable road user detection, and traffic data. Now, my question to you is, just answer with 1, 2, 3, 4. Which one interests you the more? Number 1, traffic signal control. Number 2, vulnerable road users. Traffic data, you say, in fact, all of the above interest me the most. Yep. Now, how does it work and which application do we have? So how do we do that? Well, the way we do it is working with algorithms. And we have artificial intelligence. We have what we call our first generation of AI. And how does that work? Well, what we're going to do is we're going to draw detection zones. And these detection zones are monitoring constantly what's happening out there. And we draw zones, constantly monitoring. We have sensors in there that monitor what's happening there. If a car stops into that zone, we have an output, or drives through it, we have a certain output. That's the first generation, that's AI. That's the first generation of AI. Now, the second generation of AI that we implement is, in fact, really we're going to mimic how a human brain works. How did you learn when you were a child that a car is a car? Because somebody told you, hey, that object's out there in the street, in the garage, with these wheels, with that thing, that object, it's a car. After a while, you could say, hey, that's a car. And we're going to do exactly the same thing. But we're not going to have a human brain in our cameras. No, what we're going to do is we're going to put into an algorithm, into a model. We're going to put there a lot of videos in there, thermal videos, visual videos, with a lot of situations that we know about, because we are 30 years in business. So we have quite some data where our algorithm, our AI model can work with. And in the end, it learned so good that we can guarantee that 99% of the cases, we will say, that's a car or it's a bus or whatever we need it to be. And we can still make mistakes, because 100%, sorry about that, that's not possible. And that's the nice thing about that AI, about a new generation, about that second generation, is that the sensor is really looking at the road, and whatever moves in there, every stakeholder, traffic stakeholder that moves in there, we will detect it. we will be able to trace it from the moment it moves, gets into the image, into the scene, until it leaves. We know it is. And the nice thing is, if you want to, we can know its position, its speed, its heading. We can classify it. That's all information that we can do. That's all we can do now with the new sensors, with the new AIs. Yep. And that allows us, in fact, to create what we sometimes call duplicate digital twins, because we have now so much information. Now, what are the solutions out there that have that? How can we do, what are the sensors available to us? Well, the sensors available to us are using either thermal or visual. And we have sensors using the first generation of AI and the second generation of AI. And they all have their benefits and their goals, but I will talk to each of them now separately. The first one is called our TraffiCam 2. This TraffiCam 2 is a visual sensor. It has two lenses. It's a wide and narrow angle. It contains the first generation of AI and really focused on only one thing, and that's vehicle presence. And the only thing that you get out of it is a contact closure. That's it. Nothing more, nothing less. A really simple visual sensor, as you can see, because the communication protocol is RS485. Very simple one. Then we have our TraffiOne. That is a thermal sensor. And that sensor is really focused on pedestrian, on vulnerable road users. Pedestrians could be, when we say pedestrians, we also mean cyclists and people that are walking. I call it itself the push button killer. It's really the one that we implement, put it on a pole, close to a crossing, at an intersection where people are waiting, to detect people waiting out there. It consists also out of two lenses, a very wide lens with a 95-degree angle and another one with a 65-degree angle. First generation of artificial intelligence, really focused on present action. And you can use it as a standalone, as with the push button killer. It detects and gives a contact out. That's it. Or, but you also can do it, you can connect it over BPL, broadband over power line, or you can feed it and communicate with it with power over Ethernet. These are the first generation of AI sensors, really simple one. And then we have the robust and the more complex ones. And the first one out there is the TraffiCam AI. That is a visual sensor. Has a wide angle and a narrow angle. Second generation of AI, as I mentioned, and is capable of doing presence detection, is capable of doing traffic data, but also of collecting historical data, really detailed data. Remember the videos I showed you, where in the videos you saw that there was also a speed available and a classification, but we can go more. We can really, we know exactly its position the whole time it's in the scene. We know its speed and also where it's heading. So that information, that historical data, if you want it, you can download it on your servers or on our servers. Has 5 classes and uses PPL and power reading. Here an example of how that would look like with one of the wide angles TraffiCam AIs. Well, here you see all the classes that are possible, but be careful. Not all of them can be done with a TraffiCam AI, with a visual one. So only 5 classes. That's from 1 to 5 that is possible with that sensor. And it also depends on how your camera is looking. So only the 5 classes are really possible in detail when you're close up to 20. Looking at the 40 meters with that wide angle, it's a little bit more limited. Yeah, but that's what you can do with that particular sensor. The ThermiCam, that sensor out there, what is possible with that one? First of all, it comes with 5 types of lenses. with a 90-degree, 45, 35, 25-degree angle, which allows you, in fact, if you look to the whole range, looking from 0 to about 125 meters. 125 meters is only possible with a 25 angle, looking then, I guess, from around 20 meters to 125 meters. Second generation of AI, and also presence, traffic data, historical data. But this one comes with 8 classes, because what it can do compared to a visual one, this one really can make a distinction between a pedestrian, a cyclist, a motorcyclist, because for a visual one, that's all one blur. But there we can make a distinction. And then up to 8 classes in total. Both AIs, if you want to, there's even a possibility, if you need a particular class, we can create that for you. Just mentioning, one of our customers in India was requesting, hey guys, can you detect a tuk-tuk? Ooh, was not in the normal detection. So what are we doing now? Currently, our sensor is now learning for our Indian customers how to detect a tuk-tuk. And he will do that, I think, with a visual camera that he will be able to detect rickshaws, tuk-tuks. Yep. So as I mentioned, that's our architecture, where you can have as outputs, physical outputs to do contact. You can do also API, but you have also these other 2 platforms, these management platforms I was talking about, if you want to. That is the Flux to collect and store data, but also a Cyclica. And just to show you an example, this is, for instance, how it looks like within the Flux. So that's an on-premises server where you can store, if you want to, the data being collected from a sensor or a range of sensors. Maybe you have 50, 60 cameras out there in the field collecting data, and you want to store it on premises. You could do that with Flux. Or you say, no, I want to go even a step further. One thing that you want to do is, for instance, I want to collect the data using the Wi-Fi between different sensors out there. And at the same time, I also want to collect the data from the sensors. In that case, what you need to do is you'll have to connect to the Cyclica platform, in which you will store that particular data. Because only in the Cyclica, in the cloud, at this moment, it's only in the cloud that we can handle the data between sensors using the Wi-Fi. And you can also store a huge amount of position, speed, and heading information out there. And on top of that, with the Cyclica, that's the nice thing, we have on top in the Cyclica cloud also other algorithms where you can go in detail on it. I don't know if we have an example of that one. I guess we have. Yeah, so here you see starting. So here I select, for instance, sensor. Notice, oh, that is a section I have for sensors out there. And on the left, you see also the images if I want to. Look, take a closer look on that one. And have some detailed information of that particular camera out there. That's, for instance, the data you can see coming out of it. Question for you. From all the sensors, from all the applications that I showed you, which interests you the most? I just drop a number. Is it 1, traffic cam 2, 2, traffic 1, traffic cam AI, thermocamera, flux, acyclical. Or maybe I should have a number 7 to that, all of the above. So how can you optimize your traffic? How can you make your traffic in your city safer and smoother? I hope I demonstrated that we have Teledyne FLIR ITS sensors, which can detect vulnerable road users, waiting at the intersection, crossing the intersection, but also detect presence of vehicles for traffic signal control, to collect traffic data, historical data, to learn more about your data in different ways using Wi-Fi or just on the spot. All these sensors are today more than helpful for you to make your traffic smoother, safer at the location where they are, or with Wi-Fi enabled between the sensors at more locations. But if you already jump towards sensors with AI capabilities, even you don't use it yet, but at a certain moment you say, I need more information, more data, you can activate, download all that data, either on your own servers or on the management systems that we have. Store it on those, and you have a lot of historical data with that AI. And that AI will then allow you to, in fact, create a digital duplicate of where your cameras is. In fact, if you have more of them, a digital duplicate of your city, a digital twin, which then allows you to really, check what is out there, how you can improve stuff, because you have a lot of information. You not only have a sensor that does the management on the spot, but at the same time also a lot of data to look at, okay, how was the intersection, let's say 1 year ago, and compare it with now. Is it same optimal working, or based on the data I see, it's different, it's better, it's worse. If it's worse, how can I improve it? And that is now possible with our sensors, with what we have. And on that note, I want to end my presentation, but I'm not leaving yet. So I don't know if there are questions. If so, I'm open to all these questions and open to answer them right away.
Thank you once again to Joris of Teledyne FLIR for the informative presentation on this exciting topic. I'm sure many of you may have further questions. Let's move on to our Q&A section. If you have any questions, please type in the chat box. Okay, so we got a question. What is the main benefit of using AI cam instead of common camera?
If you're talking about common camera with the normal video analytics, what is the main difference? You have cameras that have nothing, just a camera, and then it's in fact an operator who does all the job. Then you have the first generation of AI with the video analytics. That works really good already, that video analytics, but that video analytics is based on how pixels are changing in the image. Because we translate everything into black and white, we detect blobs, the way blobs behave. But the main difference with AI, it's like a human brain works. We learned that algorithm, that AI algorithm that is embedded in our sensors. We learned what a car is. It knows a car in different shapes and from different angles. It knows a pedestrian. It's really looking at the pedestrian. It sees a person. It knows what a person is in all its sizes, widths, and positions. It knows that, even a cyclist. So that is a main difference. That's a main difference. That allowed us also now, for instance, classification. With the video analytics, we were limited to 3 classes with a visual camera based on, because then daytime, nighttime, or 5 classes if we are lucky. But that was based on the length of a vehicle. So you had a car, if that car was a little bit too big, if you look at American cars, for instance, you had an American car and you had a little Italian car. Well, it was a car, but the system gave 2 different outputs with the video analytics, with the first generation. Now we know exactly what a car is. So when it's a car, it's a car. It's not going to make a mistake that it's a truck, or it's a lorry, or it's a car with a trailer. It will know all these classes. So it's much more detailed. That's the main difference with AI. And another main difference with AI is that we have now everything that comes into the scene, we will already start recognizing it. Oh, that's a traffic stakeholder. The closer it gets, then we know exactly what it's going to be. But we know already much more information the moment that something moves within our scene. Yes, that is a traffic stakeholder. So it's way more advantages that we have compared to our video analytics. I hope that is answering the question.
Okay, we got another questions from the floor. Will there be more easy for installation of AI camera? Need higher or lower position of the camera?
When we're talking about positioning with heights and so on, that will be a little bit the same rules that we have with our first generation of AI. So it's depending on the type of camera and what you want to do. We're talking about 3.5 meters up to 12 meters, something like that. For instance, for traffic data, it's always a little bit higher than, for instance, vehicle presence. But the thing is, what we always said with the first generation of AI, if we really want to have good detection, the ideal position would be try to be as close to the middle of the road. With AI, we're way more flexible. We can do way more with cameras that are positioned on the side fire, which is in fact the most common position for cameras. So on height, not much different, but the flexibility that we have now with the camera on the side, way better. Just an example. Imagine that you have a camera on the side of the road. You have a stop bar. And the old school cameras, the first generation, imagine that, okay, your camera was quite high, but a truck was stopping or a bus was stopping close to the camera. And then there was a second car coming next to that bus. There's a big chance you will not see it, will not be detected with the camera on the side. Now, with the AI camera, what can happen? It's not that your camera is looking on the side. When it's looking on the side, when a car is going next to the camera, sorry, not next to the camera, next to that bus, next to the truck, we saw it coming in. We know it's still there, although we can't see it through the camera, but the algorithm still knows, hey, that car is still there. I didn't see it driving it away, so we can keep that output. And that's the main difference. We know way more better the position of a vehicle. We know way better its trajectory, and we can use that to our advantage. Where with the first generation, when it was not seen, we lost it. Now, even when we don't see it, we can still know it in quite a lot of cases. So quite some advantages. Yeah. And maybe another example, because for installation is, yes, sometimes we need to go quite high, but then sometimes we're in the treetops. Oops, we're recovered all the time. We can go a little bit lower, and still we have the advantage with the AI, because we can trace and follow way better our vehicles getting, or vehicles, or better, every traffic stakeholder coming into the view, we have better detection. I hope that answered the question.
Thank you, Joris, for sharing your insights. Thank you once again to Joris for the informative presentation on this exciting topic. I'm sure many of you may have further questions. After this webinar, we will be sending excerpts of this afternoon's presentation with the contact details of Joris, so you may directly approach them afterwards for further questions. We will also be emailing you the CPD certificates for this event. Now comes to the end of today's webinar. Please stay tuned to our emails and communications later on for further details of the next event. In the meantime, should you have any inquiries, please contact ITH Hong Kong through email at admin@itshk.org. Thank you very much, and we wish to see you soon in our upcoming events. Goodbye.